You are looking at a $10 billion time machine that will take us on a journey to the edge of the universe. A journey that will reveal how the universe looked just 100 to 250 million years after the Big Bang. A journey that will help us understand the origin of the first galaxies and, crucially, reshape our current knowledge of the cosmos. You are looking at the largest, most sophisticated space telescope ever built. The James Webb Space Telescope. In today's episode we will see, why is it being referred as a time machine? You can see stars, planets, nebula, and most importantly, the Milky Way when you get away from city lights and stare up into the black skies. The universe, however, is not confined to what we can perceive with our senses. The electromagnetic waves that we receive from distant stars and galaxies make up the most important way to study the cosmos. However, the universe is full of regions that contain dust. Stars and planets that have just started forming also lie hidden behind cocoons of dust. Even while looking at the Milky Way, you'll see that dark dust clouds obscure a large portion of the galaxy. The problem is that stellar dust absorbs most of the visible light due to its short wavelength. This offers a hindrance in having deep insight of our universe. This is where advanced telescopes come to our rescue. Currently, Hubble is the largest and most versatile space telescope. However, what Hubble studied was primarily at optical and ultraviolet wavelengths. The electromagnetic spectrum shows that the infrared rays have a longer wavelength than the visible rays. The infrared light can easily penetrate the dusty shroud to reach us. The Webb is an infrared observatory. This will allow us to see back 13.5 billion years in time, allowing us to see photos of the early galaxies and observe undiscovered planets orbiting faraway stars. Equipped with the largest primary mirror ever to be flown in space at 6.5 meters, it's more than 6 times the size of the Hubble's primary mirror. However, infrared telescopes, like Webb, must adhere to a number of limitations. Infrared telescopes are specifically built to produce as little heat as possible. As a result, Webb must be kept at extremely low temperatures to make precise observations. Webb has state-of-the-art infrared instruments and cameras that can work in extreme cold. Its mirror and other scientific instruments would be kept at -233 degrees Celsius, which is colder than Pluto's surface. Getting this temperature is done with the help of the largest sunshield ever flown. A 5-layered tennis court-sized sunshield that blocks heat from the sun, Earth and Moon. Moreover, it will be orbiting at a distance of 1.5 million kilometers from Earth. For reference, Hubble telescope is at 547 kilometers, and Moon is orbiting at around 384,000 kilometers. Webb will be the first telescope to detect light from the most distant galaxies in the universe. These first galaxies formed about 13.5 billion years ago, only 300 or so million years after the Big Bang. Getting such a large telescope into space is an incredible engineering challenge. Fully deployed, Webb is too large to fit inside any rocket. Engineers designed it to be folded, so that it can squeeze inside the European Space Agency's Ariane 5 rocket. After launch, controllers on the ground will deploy it remotely. Webb's golden mirrors will be precisely aligned using motors behind each hexagonal segment, adjusting them to form one perfect mirror. Once the instruments are fully cooled, the exploration will begin. Webb is a technological challenge like no other. For decades, astronomers have been chasing the holy grail of seeing the creation of the first stars and galaxies. Since we are made of materials once processed in the core of giant stars, it's like searching for our own origins. So, what are your thoughts regarding the largest space telescope ever created? And will it be able to detect the birth of our universe? Let us know in the comment section. And if you enjoyed this video, support us by hitting the subscribe button. And as always, keep wondering.